Q is the concentration of the products over the concentration of the reactants at some point during a reaction, and it's used to determine whether or not a reaction is at equilibrium by comparing it to K. When Q is equal to K, the reaction is at equilibrium, and for solubility product, that means the solution is saturated, so the rate of the solid precipitating equals the rate of it dissolving. When Q is bigger than K, that means there's enough products, or aqueous ions, to make the reaction shift to the left and form a precipitate. But when Q is smaller than K, that means there isn't enough products, or aqueous ions, to make the reaction shift to the left and form a precipitate. So if you start a solubility product reaction with only the aqueous ions initially present, then a solid precipitate will form when Q is equal to or greater than K, because it means there's enough ions to shift the reaction to the left and make the solid precipitate. But if Q is less than K, it means there aren't enough ions to shift the reaction to the left, so a solid will not precipitate. The example asks whether or not the precipitate cerium iodate will form. Start by writing out the equilibrium equation for cerium iodate. Now this is not an icebox problem. What we're going to do is calculate Q using the concentration of cerium ions and the concentration of iodate ions once the reactant solutions are combined together. The total amount of solution once the reactants are combined is 1050 milliliters. The first reactant is cerium nitrate. Convert the starting amount of cerium nitrate to moles of cerium ions and then divide by the total volume of the solution to get the concentration of cerium ions at the beginning of the reaction. The second reactant is potassium iodate. Convert the starting amount of potassium iodate to moles of iodate ions and then divide by the total volume of the solution to get the concentration of iodate ions at the beginning of the reaction. Now keep in mind that the nitrate and potassium are both spectator ions because they don't participate in the reaction. We only care about the concentration of cerium and iodate ions. Now that we have the concentration of both ions, plug them in and solve for Q. Q is 5.32 times 10 to the minus 10, and K is 1.9 times 10 to the minus 10. So Q is bigger than K, which means there are enough ions on the product side to shift the reaction to the left and form a precipitate. Number 47 is very similar to the example problem in your packet. Calculate Q and compare it to K to determine whether a precipitate will form. Number 48 is a little bit different. It says that a solution contains lead ions and copper ions, and it gives us KSP for both. Iodine is added to the solution, and the question asks which will precipitate first, lead iodide or copper iodide. To solve this problem, write out the equilibrium expression for both and solve for the concentration of iodine ions. Whichever one requires the smaller concentration of iodine needed to precipitate will precipitate first.